Hello, this is Eric, and I'm going to show you how to use Graspable Math to find a line with a given slope that runs through a given point P. So our point P is at 3, 1, and let's go ahead and graph it down here in our GeoGebra plugin. This is our point. And we already know that the slope is given as 0.5. So I'm going to substitute that into our slope-intercept line equation down here. But we still need the intercept. And we're going to use some algebra to arrive at that. So I'll clone this equation here and then use the fact that this equation is fulfilled for this point P. So I can put in the x value here and substitute in the y value. And that means we now have a simple equation with one unknown. And we can just solve it. I'll bring this over here. And we arrive at b equals, the intercept is negative 0.5. So let me go ahead and substitute that in here. And this is our equation. Let's check real quick if it actually goes through point P. And it indeed does. Okay, so this is our solution. But having this done in the digital space of Graspable Math really gives us some additional benefits. And one of these is that we can actually now explore our solution space and look how things would have gone if our initial values were different. So let's say, what if m was negative 0.2 in the beginning? Then everything would have looked like this. So see how all the derivations and the geometry automatically updates. I could also do the same thing by moving this point here around. And again, everything updates accordingly. There's two more things I want to show you. One is that Graspable Math actually keeps track of all the steps you go through. So here's our whole derivation of how we arrived at the intercept. And not only does Graspable Math keep track of the steps, it also can trace terms through the derivation. So in an actual lesson, I might now go on to think about how this 1.6 consists of this 0.6 and the 1. And this 1 just stems directly from the y-coordinate, while this part here is a product of the x-coordinate and the slope. And I could connect this to parts of this diagram down here. For now, I'm just going to leave it at that though, and thank you for listening.